In this video, we are going to discuss some of the questions given in chapter number 2, Axioms of Probability, in Sheldon S. Ross, a first course in probability. So let us start on the example number 5f here. A poker hand consists of 5 cards. If the cards have distinct consecutive values and are not all of the same suit, we say that the hand is a straight. For instance, a hand consisting of the 5 of spades, 6 of spades, 7 of spade, 8 of spade, and 9 of heart is a straight for you. Now check, you need to take 5 cards having consecutive denomination. That means not all from the same suit. This is the question for you. What is the probability that one is dealt with a straight? That means you have taken 5 cards and you need to tell me the probability that the 5 cards you have got is a straight for you. So in this case, let me just denote S represents total 5 cards possible. Total combinations of 5 cards. You need to select 5 cards there. So what will be NS? NS will be out of 52, I need to choose only 5 cards. Out of 52, I need to choose only 5 cards. This is my NS. Now consider the event. Let E be the event that the hand is a straight. Let me consider E be the event that the hand I have got is a straight. So now when can I call a set of 5 a straight? Let me include a definition here. I have taken this definition from internet. If you have a sequence like this, A, K, Q, J, 10, I think the letters are self-sufficient to tell you A stands for ace, K stands for queen, and Q stands for queen, J stands for jack. So this is also called a straight and it has a special name Broadway. Other than this, you can have the possibility to have a straight like starting from A's 1, 2, 3, 4. A stands for 1, A's 1, 2, 3, 4. You can have starting from 2, 3, 4, 5, and 6 should be there. This may be the other state you can say. You can start from 3, 4, 5, 6, and 7. You can have 4, 5, 6, 7, 8. Then after 5, 6, 7, 8, 9. Then after you can start from 6 there. Check. You can start from 7. You can start from 8, from 9, and you can start from 10 also. You can start from 10 also. So all of these type of combinations will be called a state. So how many such combinations are possible? Let us just try to number them. This is the first one, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10. So if I'm telling you that a given hand of 5 is a state, so any one of them should be the combination there. Okay, any one of the combination will be there. So I need to find out how many total combinations are there. This is my NE, and the probability will be NE divided by NS. So now how to calculate NE? So assume that I have got a 5 hand having A's, then second, then third, then fourth, then fifth. This is what I have got. Assume. So it is one of the 10. It is one of the 10 cases. What is going to be the what is going to be the number of possibilities here? Out of 4 aces, let me choose one card there. Okay, there are 4 cards of denomination 2. Let me choose one of them because I need to create a sequence having one card with the ace, one another card is having denomination 2. Next card should be denomination 3 there. There are 4 cards. Next card should be of denomination of 4. There are 4 cards having denomination 4. And next card should be of denomination 5. There are 4 cards with denomination 5 there. Okay. So these are the possibilities. But there is a catch. Not all, not all cards can belong to the same suit. That means if you say there may be a possibility where you have taken cards of club, you have ace from there, you have to second denomination, third denomination, fourth, fifth denomination card from the ace. This is not a straight. And similar type of 4 suits are there. That means to say that you have to exclude those 4 cases where all the 5 cards belongs to the same suit. Okay, all the 5 cards belong to the same suit. I hope up to this point, everything should be okay. Now, if I calculate the number of possibilities for the second case, it will be the same. The third case, it will be the same. And because you are having 10 similar cases, mutually exclusive, so for total number of events, I need to multiply by 10 there. Let me tell you once more, because there are 10 mutually exclusive cases and everyone can be calculated like this. So there are total 10 multiplied by these cases. Simplify this term. What is 4C1? 4C1 is 4. Another 4C1 is 4. Another 4C1, another 4C1, another 4C1 minus 4 is there. When you simplify, it is 10. 4 exponent 5 minus 4. And you have got the answer NE there. I hope no issues are there. Even if you have issues, you can just let me know. Now, what is the probability? What is the probability of E that a hand you have got is a straight? It is going to be how much? It is an E divided by an S there. So an S is you have taken only 5 cards. So it is 52C5. And NE as we have calculated 4 power 5 minus 4. You can simplify this term and you will be able to get the answer. I hope no issues are there. It should be easy for you. So let us go to the next question. It is 5G. In 5G, read the question. A 5 card poker hand is said to be a full house. Last time was straight. This is a full house. If it consists of 3 cards of the same denomination and 2 cards of other denomination. Okay. Thus, one kind of full house is 3 of a kind plus a pair. What is the probability that one is dealt with a full house? That means you have taken 5 cards. You need to tell them it is a full house. So here I have included 2 examples of a full house. You can check first 3 cards are king there having the same denomination. Other 2 are going to be 5 there. And similarly, first 3 cards may belongs to a queen and the other 2 may belongs to aces. This is the situation. So how can we solve this question? The task is easy. First of all, NS, like in the previous example, it will represent total 5 cards you can take out of 52. It was 52C5. Just suppose, let me assume that E be the event that hand of 5 is a full house. Consider this is the case. I need to calculate NE. So how can we calculate NE? So for calculating NE, let me just create 5 possibilities. First, second, third, fourth, 5. There are 5 cards you can have. The first 3 cards should belong to the same denomination and the last 2 should belong to the same denomination. Then you will have a house there. So like K you have, you know that you have denomination ace 2, 3, 4 up to 10, then after jack, queen, king. So there are 13 denomination you have. And for the first 3 places, I need only one denomination. So out of 13, let me just choose one denomination. Like you have chosen king here or queen here, you can have 13 denomination like this. You have 13 denomination like this. So if 13 denomination, just suppose you have chosen king there. Just suppose we have taken king here for like this example. So there are 4 kings you have. So how many possibilities are there? We need to place 3 kings only. There are 4 kings you have. Again, out of 4 king, I need to choose only 3. Why I need to choose only 3? There are 4 suits. I have only 3 positions. So I can only take 3. This is one such case. So in this way, up to now, I have taken 4 cards. I have taken 3 cards of the same denomination. Now I will repeat the same structure for the next case. For the next case, I need to choose the left out denomination. If I have taken one denomination here, so there will be 12 denomination left. And out of those 12 denomination, I need to choose one. Like you have chosen 5 here. So out of 12, you have chosen one denomination, like 5 is there. So because you are having 4 cards with the same denomination, and you have only 2 places, so out of 4, I need to choose only 2 cards from there. So this way, I will be having a pair of cards having the same denomination. So now if you calculate your NE, it will be 13C1 is 13, 4C3 is 4, 12C1 is 12, and 4C2 is going to be 6. I hope the calculation will be easy for you. You can easily calculate them. So if I ask you the probability that a given hand is a full house, you will tell me it is simply NE divided by NS. We have the value of NE there, and we can divide by 52C5, and this will be your final answer. I hope no issues are there. Let us go to the next example. Next example is 5H there. And here we need to talk about a bridge. We need to talk about a bridge. So in the game of bridges, the entire deck of 52 cards is dealt out to 4 players. 52 cards you have to dealt out to 4 players. You have to distribute them. What is the probability that one of the player receives all 13 spades? B, each player receives one ace. These are the 2 questions there. So whatever I have given the definition here, it is for your reference only. So 52 cards I need to distribute to 4 players. So for this purpose, I'm going to use the multinomial. In multinomial, there are 2 things you need to always remember. First is distribute. Second is groups. So whenever you need to distribute like here, 52 cards into 4 players. So everyone is getting 13, 13, 13 there. In distribution, the total ways are going to be multinomial 52, then after first 13, second 13, third 13, fourth 13. This is how you have distributed 52 cards into 4. And because you are going to distribute them, whenever distributing is there, the order is important. The order is important. In this case, we'll leave it up to this point. In case there is a grouping only, in case there is a grouping, in that case, I'm going to divide by the number of repetitions here, that is 4 factorial. In case I ask you the question that you need to group 52 cards into 4 groups only, then the answer is going to be 1 over 4 factorial. Okay, you need to multiply by 1 over 4 factorial. Right now, because 4 players, I have to dealt out to 4 players. So that means I have to distribute. So the number of possible ways are going to be 52, 13, 13, 13, 13. Let me tell you this important thing once more. So just suppose S is representing total distribution to 4 players. because you have to distribute. So what will be my ns? My ns is going to be 52 distributed to 13, 13, 13, 13, and that is all. Order is important here. If you wish to calculate them, it will be 52 factorial divide by 13 factorial, 13 factorial, 13 factorial, 13 factorial, or you can write like 52 factorial divide by 13 factorial exponent 4. I hope no issues are there. Now, let us discuss part A. One of the player receives all 13. There are 52 cards and one player receives all 13 there. So out of 4 player, so maybe I need to choose one player who have got all 13. So out of 4 player, let me write E first here. E is the event that a player receive receives all 13. So if I need to find out NE, I need to choose the player first. There are 4 players. Choose one player who have got all. Choose one player who have got all the spades. Okay. So, and rest 3 are going to have 39 cards and you can distribute them. So in this case, 39 spades are going to be distributed to this particular player. About 39 other. These 39 other cards, because total cards are 52, you need to distribute to 3 players. So everyone is going to get 13 there. Again, I'm using multinomial. Let me tell you once more. First, I have chosen a player who have got all the spades. Who have got all the spades there. How can I choose one player? Out of 4 players, I am choosing one player. Out of 4 player, I am choosing one player. Okay. And next, out of 39 left out cards, I'm going to distribute the card into 3. I'm going to distribute the card to 3 players. So distribution, so that means multinomial can be used. So 39 divided into 13, 13, 13 there. You can simplify this term. If you simplify, the first term is 4 there. 13C3 is 1. And you can distribute like 39 factorial divide by 13 factorial, 13 factorial, 13 factorial, or you can write them like 13 factorial divide by, sorry, like 4 multiplied by 39 factorial divided by 13 factorial whole power 3. These are the two cases. So what is the probability here? The probability of E is going to be the number of cases favoring E divided by total number of cases. And E stands for 4 into 39 factorial divided by 13 factorial whole power 3. And you have to divide by ns. So whenever you are dividing by ns, it is the same thing if you multiply by the reciprocal of denominator. So I'm multiplying by the reciprocal of denominator. You just simplify, this is going to be 52 factorial there. I hope no issues are there. It is 52 factorial there. Now you simplify this term. You simplify this term, it is 4 into 39 factorial. It is going to be 13 factorial divided by 52 factorial. Reason being, there are 3 powers in the denominator of 13 factorial. 4 power is here. So 3 powers will be cancelled out. You will be having only 1 power of 13. 39 is already there. And now you can further simplify them. 39 and 52. If you wish to simplify, let me just write down. 39 factorial divided by 52 factorial may be written as, it is 39 factorial divided by, you will have 52, 51, 50, 50, and up to you will have 40, then after 39 factorial. And if you write this 39 will cancel out this 39. So when you take this into account, you will be having 4 into 13 factorial divided by 52 into 51 into 50, and you keep doing the same, you will be having 40 in the end. You will be having 40 in the end. And when you simplify this term, you will be having 4 into, it is 13 by 52. You can write 12 by 51. You can write 11 by 50, and up to so on, and you can have 1 over 50 like this. When you calculate this sum, you will be having answer around 6.3 into 10 raised to the power negative 12. Okay, you will be having a solution like 6.3 into 10 raised to the power minus 2 there. I hope no issues are there. There is other way of doing the same question, like from here I can write this expression, this whole expression, as it is the reciprocal of 52C13, and this type of calculation is given in the book. So I have followed a different path to solve this question, and if you wish, you can just follow the book. Okay, this is the A part. Now in B part, what is the question? Each player receives 1 ace. So you need to find the probability if each player receives 1 ace. Let us start the B part here. We did the A part in the previous slide. Each player receives 1 ace. Okay, so there are 4 players. So if each player receives 1 ace, that means out of 52, there are 4 aces and there are 48 other cards. And we are going to distribute these left out 48 cards to 4 players. And every player will then receive 12 cards. Okay, so let me represent EB in the event of case B. Okay, everyone receives 1 ace there. This is the event there. I need to find any. So in order to find any, first distribute 48 cards to 4 players. You distributed using the multinomial, 48 distributed. Because it is a distribution, so order is important here. Next, because you are having 4 aces and you can distribute 4 aces, because you are having 4 aces, you can distribute them in how many ways? If you distribute them, there are 4 factorial bases. You can distribute them. So this will be your NE. So what is the probability in this case? Before the probability, let me just again simplify above structure. It will be 48 factorial divided by 12 factorial, 12 factorial, 12 factorial, again 12 factorial multiplied by 4 factorial, may be written as 48 factorial divided by 12 factorial whole power 4 multiplied by 4 factorial. This will be our NE. So now if I need to find the probability there, what is the probability of event E? Every player must have got 1 ace, is going to be simply NE divided by NS. It is going to be 48 factorial multiplied by 4 factorial divided by 12 factorial power 4. It will be numerator, and the denominator is going to be, denominator was NS. NS we have already calculated. So I'm just trying to multiply them by the reciprocal of NS, that is 13 factorial power 4 divided by 52 factorial. So if you wish, you can calculate the answer using calculator. Now after this, we have next example 5I. So let us first read the question, then after we'll try to discuss. 5i question is, if n people are present in a room, what is the probability that no two of them celebrate their birthday on the same day of the year? No two of them celebrate the birthday on the same day of the year. Okay, this is the first task. The second task here is how large n should be that the probability is less than 1 by 2. This is the second task. So consider this as the first task. Let me use it #1 there, and this is #2. I need to solve for #1 there first. So just suppose, to simplify or to understand the problem, just suppose n is going to be 3 there. There are 3 people in a room, and I need to find out the probability that no two of them have the same birthday. Okay, so first of all, how many total possibilities are there? S represents the total possibilities. First person can have a birthday on any day in a year. I'm assuming that we are considering 365 days in a year. The second person can have a birthday on any day in a year. And similarly, the third person can have a birthday on any particular day out of 365. So how many total possibilities are there? The answer is going to be 365 power 3, because you need to find the possibilities together. Now, just suppose E be the event that no two have same birthday. No two per people have the same birthday. I need to calculate the possibility. So what about the first person? First person can have birthday at any day out of 365. Okay, out of 365. In case if I have chosen any day out of 365, the second person can have birthday out of 64 because one day already taken, and no two person have the same birthday. For the third person, we only have 363 cases. Okay, because the third person cannot have birthday for 2 days. 2 days, first day was selected for the person one, second for the person two. So how many such possibilities are there? So if I ask you what is NE, you will tell me it is going to be 365 multiplied by 364 multiplied by 363. So the probability of E for this particular case is going to be 365 multiplied by 364 multiplied by 363 divided by 365 whole power 3 there. I hope clear. Now let us generalize the case. So in generalizing the case, I will not restrict myself for 3 person only. So assume that there are n people in the room. So in this case, if I ask you how many total possibilities for birthdays, 365 possibility for the first person, 365 for the second person. Every person have 365 possibilities. Any day out of 365 will be the birthday. So how many possibilities are there? Answer is 365 whole power n. These are the total possibilities you have. And like we discussed, E, and E stands for no to have the same birthday. First people you have chosen can have the birthday out of 365 days, any day. The second person will have to have 364 days only because one day is already taken by other person. Now 2 days were taken by other person, it is 363 there. And up to what will be the last situation? The last is going to be 365 minus n plus 1. Now the question is why plus 1 is there? It is just a observation. For the first person, you are having 365. For the second person, you are having 364. For the third person, you are having 363 there. That means for the nth person, we are subtracting n minus 1. Check. For the first person, n equals 1. I am subtracting n minus 1, that is 0 from 365. For the second person, I am subtracting n minus 1, that is 1 from 365. For the third person, I am subtracting n minus 1, that is 2 persons here. So I have calculated NE. And if you have calculated NE, you can find the probability. You can find the probability. Let me just write probability PE here. It is 365, 364. The last is going to be 365 minus n minus 1 divided by 365 whole power n. So this is how you can find the probability that no two person have the birthday on the same day. Okay, I have got an interesting result here. You can write them. You can write them in this format: Pn 1 minus 1 over 365, 1 minus 2 upon 365, and up to so on. And I'm not going to just tell you whole expression here, but I can solve one of them. If you take the case P3 there, P3 you are having 365 multiplied by 364 multiplied by 363, like I discussed you earlier. When you divide by 365 power 3, so actually you can write them like this. And if you calculate first term 365, maybe cancel out the first term. 364 you can write like 1, 365 you can write like 1 minus 1 upon 365. Check simplification will give you the answer. Second pair 363 by 365 there, it is a mistake, it should be 5. I'm sorry, it should be 5 there. The second expression you can rewrite like 1 minus 2 upon 365. So if you have got n persons there, you have to go up to n minus 1 divided by 365. It is an expression here. So now we need to find out the value of n for which Pn is less than 1 by 2. No two person have the same birthday. So we want Pn is less than 1 by 2 there. So they have calculated this expression. It is n1 minus Pn, and when the value of n is 23, it is 50.7% there. It is 15.7% there. So therefore, at least 23 people in the room, in order for the odds to favor at least two of them having the same birthday. So you can read these two paras and you can argue the last part of the question. How large n should be so that this probability Pn is going to be less than 1 by 2. So n should be 23 or bigger than equal to 23 to get this probability Pn less than 1 by 2. Okay. If there is an issue, you just let me know. I'll try to answer the query. Next question, just have a look at the next question. A deck of 52 playing cards is shuffled and the cards are turned up once at a time until the first ace appears. Until the first ace appears, is the next card, is the card following the first ace, is more likely to be an ace or 2 of clubs. Okay, 2 stands for the denomination. The card is second of club. Clear? So that means to say that first, out of the 52 arrangement, you first find out where is the first ace you have got. And after getting first ace, you need to check whether the very next card of first ace is an S of spade, or this very first card is a 2 of club. This is the question. So how to answer this question? First of all, let me represent S by total arrangements of 52 cards. Here wording arrangement is required. Reason being, after one ace, you need to have another ace or a two of clubs. So how many arrangements are possible? You have 52 cards. So there are 52 factorial arrangements are possible. Okay. Next, just suppose E be the event. Let me represent E1. It is the event that the next card is an ace of spade. Next card is after the first ace. After the first ace, the next card is going to be a spade. E2 will be the event for two of clubs. So now how can we find n of E1? So in this case, what you do, you just keep this 51 as sorry, you just keep this one ace card of spade separate, and you arrange rest 51 cards. You arrange rest 51 cards. Let me tell you once more. In order to answer this question, that after getting first ace, next card is a ace of spade. Let me just keep out this first ace card of spade out, and let me just try to arrange 51 cards. So if here is the place where I get first ace, I need to just plug the card here. And if I plug the card very next to the first of ace, I will be satisfying the condition E1 that after first ace, I have got a ace of spade. So technically, this question is basically arrangement of 51 cards, and I will put the ace there after the first of ace. So how many arrangements you can have of 51 card? It is 51 factorial. So what will be the probability of E1? The probability of E1 is going to be probability of E1 is going to be n E1 divided by ns, and E1 is 51 factorial divided by 52 factorial. When you simplify, the denominator is 52 multiplied by 51 factorial. It is 1 over 52. It is 1 over 52. This is part 1. If you consider the second event, assume that second event E2 is the event that the next card is a two of spade. Next card is a two of spade. So I need to find out an E2. Like similar case, let me just keep this card out, and I arrange rest 51 card. Keep this card out. And when you get the first ace, you just place this out card, this two of, sorry, it is two of club there. It is two of club, sorry, it is two of club card. It is two of club. You just place this two of club card there. So I hope it is an identical case to the last. So the total possibilities are going to be 51 factorial again. And the probability of E2, like we discussed, is going to be like the previous case, identical case, it is 1 over 52. Just have a look at the question. A football team consists of 20 offensive and 20 defensive players. The players are to be paired in a group. Check, you are just pairing them in a group. Ordering is not important in a group. But if you distribute, then order is important. For the purpose of determining the roommates. Okay. If the pairing is done at random, what is the probability that there is no offensive defensive roommate pair. This is first part of the question. Second part is, what is the probability that there are two I offensive roommates and pair I goes 1 to 10? Let us answer one by one. Let me just answer the first part. So first of all, there are how many players you have? 20 offensive and 20 defensive players are there. In total, you are having 40 players. So you need to distribute these 40 players to 2. So S represents total grouping of 40 players in 2 in pair. Total grouping in pair. So when you do so, what will be NS? 40 players will be dividing into two groups, 2, 2, 2, and up to 2 using the multinomial. How many groups are possible? There will be 20 groups are possible. And because only grouping is required, order is not important, you're going to divide by 20 factorial also. Because grouping is required only, so you are going to divide by 20 factorial also. This is total cases. Next, consider that E with the event that no offensive defensive roommate pairs. E with the event that no offensive and defensive roommates pair. So that means to say that there are 20 offensive players. They are going to be having 10 groups of 2, 2, and 2, and 20 defensive players. You are going to have 10 groups of 2, 2, and 2. I hope this is the situation, because you cannot have both. You cannot have offensive defensive roommates together. So offensive players will be distributed among them in the group of 2, and 20 defensive are going to be distributed among them only. And because distributing not distributing, because we are actually dividing them into groups of 2, order is not important. So for the first case, I'm going to divide by 10 factorial, because there will be 10 groups. And for the second case also, I'm going to divide by 10 factorial. This will be my NE. So if you answer the question, it is going to be 20 factorial divided by how many groups are there of 2? There are 10 groups. Order is not important. And for the second case, 20 factorial, how many groups of 2 are there? 10 groups are there, multiplied by 10 factorial in the denominator. So in short, you can write 20 factorial divided by 2 factorial power 10 into 10 factorial whole square if you calculate them. So if no issues are there, the probability of E is simply E over NE divided by NS. This is the answer. NE divided by NS there. I hope no issues are there. Next, in the second case, number 2, let me read the question once more. What is the probability that 2 I offensive and defensive roommate pairs? Out of 40, you need to have 2 I offensive and defensive, okay, pairs. So let me represent this term. Actually, in the book, they are representing it by 0 there. That means no offensive and defensive roommates are paired. So let me represent by P of 2I stands for the 2I offensive and defensive pairs are there. It represents probability that 2I offensive and defensive pairs are there. Out of 20 pairs, 2I pairs are going to be offensive or defensive. In this case, you can talk about P0, you can talk about P10, you can talk about P20 there. Reason being, there can be maximum 20 such groups here. Okay, 20 such groups. So how can you pair 2I offensive and defensive? What is the possibility there? Let me consider E be the case here. Let me consider E be the event that 2I offensive defensive pairs are there. 2I offensive and defensive pairs are there. If 2I are there, rest will be offensive will be paired separately and defensive will be paired separately. Okay, so how many such possibilities are there? Let us calculate. So let me just have first offensive here. Out of 20, let me just take 2I out. And I'm going to pair them with the defensive. Out of defensive, 20 defensive 20 defensive players are there. Let me take 2I out. And I'm going to pair them. I'm going to pair them. If you're going to pair them, let me just tell you one result. If I get the space, yes. So just suppose there is a situation, capital A, B, C, D, and there is small a, B, C, D, small. You have to pair them. How many possibilities are there? A can go anywhere, B can go anywhere. So whenever you have to pair them, the total possibilities are going to be simply equal to the n factorial. Here n is number of observations. It is 4 factorial for you. So when two I persons are there from offensive, 2I from the defensive, total how many you have got? So 2I% offensive, 2I% defensive, it is 4I. It is 4I technically, total 4I basically, but you have to pair them. How many pairs are possible? I need to just count factorial of 1. I'm going to multiply by 2I factorial here. Check. I'm going to multiply by 2I factorial. There are total 4I persons. Out of there are total 4I persons. 2I from offensive, 2I from defensive. I need to pair them. One offensive, one defensive. So in this case, it is going to be 2I factorial, like the example I have given you. I hope no issues are there. Left out players. Left out players. So what about the left out players? You are having 20 minus 2I offensive players and similarly defensive players. So whatever I do for one, it will be the same for the other. So I'm just using a square here. So I need to distribute them. I need to distribute them into a group of 2. So 2, 2, and up to 2. How many such groups are possible? Earlier you are having 2, then after 2, then after 2, and such kind of 2. 10 groups were there initially if no pair of offensive and defensive were there. And in total you are having 20. Because you have taken 2I out, you have taken 2I out. That means 10 minus I, because you have taken 2I out. So how many pairs are left? 10 minus I pairs are left. So how many groups are there? 10 minus I factorial. 10 minus I pairs are there. And because as you know, we are just dividing them into groups there, you need to divide by the 10 minus I factorial, the number of repetitions. So when you calculate above structure, let me just erase all here. Let me just erase all. And this is going to be 20 C20I, both are 2 square, multiplying by 2I factorial. This within this square bracket, you can rewrite 20 minus 2I factorial because I have used a this term is a multinomial term. Multinomial term. Divide by, you are having 2I to the power 10 minus I because there are 10 minus I group, multiplied by, so divide by 10 minus I factorial because ordering is not required. This will be your NE, and from now you can easily get what is your PE. You can easily get. So P is going to be simply NE divided by NS. You just substitute the value of NE and NS, you will be able to get the answer. So quickly we go to 5L after this. If you have any difficulty, you just let me know. I'll try to answer the question again. This type of question you may have seen in class 12th also. A total of 36 member of clubs play tennis. There is a group of tennis player. There is a group of tennis. Let me just highlight. 36 members play tennis. I need to highlight. 28 squash and 18 play badminton. 22 members play both tennis and squash. 12 play both tennis and badminton. And 9 play both squash and badminton. 4 plays all the three sports. How many members of the club play at least one of the game? At least one of the game. So just suppose I'm representing tennis by T there, squash by S there, badminton by B there. So they have given me what is my NT, number of players playing tennis. My NS is number of players playing squash. My NB, number of players playing badminton. And number of players playing tennis and squash. So and squash is intersection for you is 22. Number of players playing tennis and badminton is 12 there. Number of players playing squash and badminton, sorry, it is squash and badminton, it is 9 there. There are 4 players who play both, who play all, sorry. So they're asking you at least one player. How many players play at least one player? So whenever at least is there, you need to find the union. Union stands for at least one is there. I hope you remember the formula from class 12. It is going to be sum of single terms, sum of single minus subtract, use subtract intersection of 2 at a time. So it is T intersection, it is S intersection B there, it is S intersection B. I have already taken T intersection B was left. T intersection B was left. It is T intersection B there. And then you add all intersection of all together. You calculate this term. It is going to be first 36, 28, 18. T intersection X is 22. Then after S intersection B is 9. Then after 12 there. Plus you will have 4 all. And I hope when you simplify, the answer is going to be 43. So 43 members play at least one of the sports. This is the answer for this question. Okay. Next, we are having questions based on the rearrangement. We will discuss these questions maybe in the next videos. I hope you get the answers. Thank you.